Good morning, guys. Welcome back to my channel. And in this video, I am going to start with Markovnikov rule. Now, this is an important topic if you are trying to understand some of the organic chemistry reactions and stuff. And this is also an important part of hydrocarbons. Now, when it comes to your Markovnikov rule, let me choose a nice pen for you guys so that you can understand. Okay, when it comes to your Markovnikov rule, the thing to keep in mind is that this rule is used for unsymmetrical alkanes, unsymmetrical alkenes. So what are unsymmetrical alkenes? Unsymmetrical alkenes are something like this. So if you have this sort of carbon structure, then you can see that there is no line of symmetry. This part is not same as this part. But when it comes to your symmetrical alkene, this part, if I draw a line of symmetry, this part is same as this part. This is your symmetrical alkene and this is your unsymmetrical alkene. Having said that, let's move on to the definition. For an unsymmetrical alkene, so this is your unsymmetrical alkene, and this is not your unsymmetrical alkene. So this is only for unsymmetrical alkenes. So for an unsymmetrical alkene, if we add an identity is like a compound. We just call it an identity here, where there is a polarity difference. Now, what is a polarity difference? Polarity difference is something like this. If you have a hydrogen atom bonded to any atom which is having more electronegativity, let's say it is bromine. This is your halogen. This is your very famous halogen, and if this is bonded to bromine, let's say the polarity difference is more. So obviously bromine is more electronegative than hydrogen, so it will try to attract the electrons toward itself. So it will have a partial negative charge and hydrogen will have a partial positive charge. Why do we say that this charge is partial? Because these electrons have not been transferred to bromine completely. That only happens when the bond will break. Still, the electrons are near bromine, so we can say it is partially negative, not completely, because this bromine does not have the electrons yet. That will only happen when this bond breaks, wherein the bromine will become completely negative and hydrogen will become completely positive. So this is your polarity difference. There's a polarity difference here. Then the negatively charged part. Now obviously the negatively charged part in hydrogen bromine is your bromine. Hydrogen bromide is your bromine is your negatively charged part in your hydrogen bromide. Similarly, if you consider hydrogen chloride, so chlorine is your negatively charged part because it is more electronegative. Okay, so you got an unsymmetrical alkene, you got a polarity, you got an identity with a polarity difference. Then the negatively charged part of this identity, so this negatively charged part or this negatively charged part will get attached to the double bonded carbon atom having less number of hydrogen atoms. So let's look at this reaction properly. Let's look at this complete reaction. So if I am having an unsymmetrical alkene, let's say I'm having propene, so CH3 single bond CH, what is it, CH, yeah, CH, and double bond CH2. This is my unsymmetrical alkene. There is no line of symmetry here. I can't, make it turn it into half or make both sides same. So this is your unsymmetrical alkene. This is your propene. This is your propene. So this is your unsymmetrical alkene, and I'm going to add an identity with a polarity difference. So let's say I'm adding your hydrogen chloride or hydrogen bromide. In this case, I've taken hydrogen chloride. So I'm going to add this this identity with polarity difference. And according to the rule, what does the rule say? Once more, let's see. It says that attached to the double bonded carbon atom having less number of hydrogen atoms, the negative part will get attached to the double bonded carbon atom having less number of hydrogen. So in this case, let's see which carbon has less number of hydrogen atoms. Now, one thing to note here is the fact that children tend to make mistakes. They tend to include this carbon atom also or any other carbon atom here. Always remember the carbon atom is double bonded carbon atom. This chlorine, which is your negatively charged species, will go and attack your double bonded carbon atom. So either it will attack this or it will attack this. It will never attack this carbon atom because it is single bond. It is attached with a single bond. So it will never attack this carbon atom. It can only attack your double bonded carbon atoms. Now Markovnikov rule says that it will attack the carbon atom having less number of hydrogen atoms. So in this case, you can see there is only one hydrogen atom, and in this case, you can see that there are two hydrogen atoms. So obviously, according to the Markovnikov rule, this chlorine will go and attack your CH, this carbon atom, your secondary carbon atom, because it is having less number of hydrogen atoms. So your product will look something like this: CH3, then single bond C, single bond hydrogen atom, single bond chlorine atom, and your single bond CH3. This hydrogen atom will go and attack your CH2. Okay, that is your product. This product you'll get. This is your halo alkane or alkyl halide, whatever you will like to call this particular product. The thing we are focused on is your Markovnikov rule. Now, how does this Markovnikov rule actually occur? What is the mechanism behind Markovnikov rule? Now, don't worry, children tend to get very, easily get worried when it comes to mechanism of reactions. But if they tend to, understand mechanism by relating it to, certain real life examples, they can understand it in a much better way. Okay, I'll try to make it as easy as possible for you guys as well. Okay, so I'll write this reaction once again. This is my CH3 single bond CH double bond CH2. This is my propene, and then I'm going to add a hydrogen chloride or hydrogen bromide, anything you like, just there should be a polarity difference, and I will get this particular structure: CH3CH Cl double bond CH, single bond CH3. Okay, there's a single bond here. Okay, now let's look at the mechanism. How does this Markovnikov rule occurs? What is happening? What is happening behind the scenes of this particular chemical reaction? Okay, let's talk about this polarity difference, this species, this identity with a polarity difference. Let me write this identity like this. Let me represent it with a bond. There's a bond present between this hydrogen and chlorine, and if we break this bond, what will happen? Chlorine is more electronegative, so it will take the electrons of hydrogen as well as chlorine. So hydrogen will get a positive charge and chlorine will get a negative charge. This bond will break and hydrogen gets a positive charge and chlorine will get the negative charge, because chlorine has taken away all the electrons, because it is electronegative, it takes away electrons, and hydrogen will get a positive charge. Now this hydrogen atom present here with a positive charge, it is having a positive charge, which means someone has taken away its electrons. So this chlorine atom, he is a thief, okay? He has taken the electrons of hydrogen, and now hydrogen needs electrons. It is wanting electrons, it requires electrons, and it has a demand of electrons. So since it is having a demand of electrons, what do we call such species? Those species which love electrons, what do we call them? We call them electrophiles. Electrophiles. So this hydrogen atom here is going to act as an electrophile, because electro means electron and philes means loving. So this is an electron loving species. It's going to love electrons. It's demanding electrons because it has just lost its electrons. Okay, since it is having a demand of electrons, it is going to attack. Now where will it attack? Where can you find electrons? Where will it find its electrons from? So if you look at this structure here, right here, yeah, this is your propene. If you look at this propene, you can see a pi bond present here. So there's a pi bond present here, and this pi bond, it is having loosely bonded electrons. So obviously this hydrogen atom will go and attack one of these carbon atoms here and will form a bond and will get its electrons. Now this is your electrophilic addition, because this hydrogen atom is going to add to this propene or your alkene, and it is an electrophile. So this hydrogen atom is an electrophile because electrophile is electron loving. It wants electrons, it is in need of electrons because it just lost its electrons, and it is also going to add. So it is also going to add, or it is going to attach, or it is going to attack your carbon atoms. So we use this word, and we call this reaction, this attachment of hydrogen atom, or this attack of hydrogen atom, as your electrophilic addition reaction. This is your electrophilic addition reaction. And it occurs in Markovnikov rule. Okay, so remember this. This might form an important question for you guys, or it might come in handy when you're learning some other chemical reactions where Markovnikov rule might be used. Okay, let's move on. Let's let's get a new page and understand this more further. What is happening in the next step? So in this step, hydrogen atom has hydrogen atom had lost its electrons. It's going to attack to carbon atom to get its electrons and become stable. Everyone wants to become stable. Electrons are like money, by the way. Everyone wants to get electrons and they want to become stable. Similarly, this hydrogen atom, someone stole its electrons, and you know who? It was chlorine, and he wants its electrons back, and somehow he has a demand of electrons. And where is it going to find its electrons? Well, yeah, you would have guessed it already, from propene. So because propene has a supply of electrons and hydrogen has a demand of electrons, and there it gets it from. Okay, in our next step, let me draw the structure once again of propane: CH3 single bond CH double bond CH2. Now your hydrogen atom can come and attack this particular propane in two ways. So it has two particular ways of attack. Don't worry, I'm going to make it easy for you guys. Don't need to worry. Now your electrophile hydrogen is going to attack this structure. How does that occur? How does this happen? It can happen in two ways. In one way, what it could do is Now, this will be based completely upon the shifting of your pi electrons. These are pi electrons present here. They could shift to this carbon atom, or they could also shift to this carbon atom before hydrogen atom attach. If they shift to this carbon atom, your primary carbon atom, let me consider it as A, then what happens? If they shift there, the structure will look something like this: CH3CH single bond CH2. The structure will look something like this. This carbon atom will get your positive charge and this carbon atom will get your negative charge. Obviously, hydrogen will be attracted to this carbon atom because it is negative, so positive negative attract to each other. Also because this is having electrons. This carbocation, the carbon which has positive charge is called your carbon, is called your carbocation, and because it is a carbocation, it is electron deficient. So hydrogen is already electron deficient. Why would it go and attack your carbocation? Instead, it will go and attack your CH2, which is electron sufficient. It has a supply of electrons because it just got its electrons, it just got pi electrons. So hydrogen will go and attack this and will form a bond with this CH2. It will form a bond with this CH2, and finally you will get your product something like this. Okay, this is your carbocation and your hydrogen atom just got attached, so this will become your methyl. Your third hydrogen atom is this hydrogen atom. Okay, this will be your structure from here. Now, one more thing could happen is that these pi electrons can go and shift to this carbon atom. That's also a possibility. These pi electrons can go and shift to this particular carbon atom. And how does that happen? How will our structure look like when that happens? So CH3, our structure will look something like this: CH3, then you will have your let me write it like this CH, and it will have a negative charge, and this will have a positive charge. This will be your carbocation in this case. Your primary carbon will be your carbocation in this case, and your secondary carbon is a carbon which is attached to two carbon atoms, and your primary carbon is a carbon which is attached to only one carbon atom. So your secondary carbon atom in this case will be your will be negatively charged, means it is having a supply of electrons, and obviously hydrogen will be attracted to your negatively charged one because it is positive, and positive negative attract each other, and this carbon and anion has a supply of electrons, and this has a demand of electrons, and it will form a bond, and our structure will look something like this: CH3 CH2 single bond CH2 and the carbocation. Now these are our two structures that we just got. Now out of these two, which one will be more stable? Remember, this is the order of stability: your tertiary, secondary and primary. Most stable is your tertiary, then is your secondary carbocation, and then is your primary carbocation. This is the order of stability of carbocation. So out of these two, which one is more stable? Obviously your carbocation, this is your secondary carbocation which is attached to two carbon atoms. That is why it's called secondary carbocation. That is more stable according to this trend, and this is your primary carbocation because it is attached to only one carbon atom, and this is less stable according to the trend. So this will move forward in the reaction, and this will go and form the major product of your reaction. Okay. Now what happens next? So this will go forward in the reaction. This is our hero because it's more stable. Let's look at our structure. Now what happens next? So your CH3 single bond CH plus and your single bond CH3, this is your secondary carbocation. This is more stable. It's more stable and it will move forward in the reaction. So the other one, your minor product, the other primary carbocation will not, the structure with the primary carbocation will not move forward because it was less stable. It will try to be more stable by going backwards to where it started when it was more stable. Since it is more, this carbocation, your secondary carbocation is more stable, it will move forward in the reaction. And now what happens? It is still unstable. It's stable, but it is more stable than your primary primary carbocation. But this is still unstable because it is still wanting electrons. It requires electrons. It is also like a thirsty lion which is wanting electrons, or it's like that thief which wants electrons, which needs electrons. It's like normal people who want money. Everybody wants money. Similarly, this carbon atom, it wants money, it wants electrons, it wants money to become stable, it wants electrons to become stable. And where does it get it from? Now, remember we got a negative entity from hydrogen bromide when this bond break. Yeah, when this bond break, we got Br minus as well with the H plus. Now, H plus already it took part in the reaction, and it had got attached to this carbon atom forming a methyl group. What about this bromine atom? Yes, this is where it is happening. Now this bromine atom will go and attack to this carbon atom with this carbocation, because positive negative attract each other. So CH3 CH positive CH3 plus bromine will give you CH3 CH bromine and your CH3. So this is your bromine, or if it was chlorine, then it will be chlorine. Any halogen atom or any atom which is having electronegativity difference or polarity difference. Okay, this one is your structure that is formed, because this was your carbocation, it needed electrons. This is bromine, it had an electron, it had one extra electron. So obviously this, what is happening is that this carbocation will go and attach to this, or this bromine will come and attach to this carbon atom, because positive negative attract each other. They are going to form a bond. Here sigma bond is formed and our structure is formed. Now this takes us back to Markovnikov rule. Now what did Markovnikov rule say? He said that the negative entity, you can see this negative entity, it will go and attach to the carbon atom, to the double bonded carbon atom having less number of hydrogen atoms. So this was the carbon atom having less number of hydrogen atom. This was the carbon atom which was having one hydrogen atom, and when it came to double bonded, and it really did go and attach to this carbon atom, and it really did form a bond. And this proves our Markovnikov rule. This is where it all ends. Thank you for watching, and if you have any doubts on Markovnikov rule, please do leave them in the comment section. And also, if you find any mistakes in this video, because I'm a human, I can also make mistakes, then please write them down in the comment section, and I will try my best to not make any mistakes. And if you have any more doubts, or if you want me to make any videos on any difficult concepts, please write them down in the comments. Thank you for watching. See you next time.